Biochemistry begins with an understanding of carbon. Carbon is an element, therefore it has atoms. You're looking at a carbon atom right now. Now atoms have, at their center, a nucleus. That nucleus contains protons and neutrons. Carbon, the nucleus of carbon, specifically has 6 protons and 6 neutrons. Together, that adds up to 12. So this is an atom, or this atom is called carbon-12. Atoms also have electrons. You can see these electrons sitting outside of the nucleus. Electrons are found at very specific distances from the nucleus, and only at those distances. They can't be anywhere else. Because of this, electrons form energy levels. There are specific distances, and everywhere that distance is away from the nucleus, you'll find electrons. They form like a dome or a cloud around the nucleus. This is the first energy level, and right here is the second energy level. Carbon has 6 protons. The number of protons is equal to the number of electrons. So carbon has 6 electrons. When you put the electrons into an atom, you always fill the inner shells first. So let's put these 6 electrons in place. We have 1, 2, and that fills the first energy level. The first energy level is small and will only hold 2 electrons. Secondarily, electrons like to be paired. By pairing the electrons, while this model shows these electrons at opposite ends, it is not where you actually find electrons. These electrons will be paired, so they'll be together. Paired up. One will spin one direction, the other will spin the other way, and that's what holds them tight together. Electrons that are paired do not interact with the world. Only single electrons interact with the world. So, we had 6 electrons to place. We put the first 2 in the first energy level. Those first 2 electrons pair up in that first energy level, and they fill it. Because they're paired, they do not react with the world. You come out here to the second energy level. We've already used 2, so we have 4 left, and we put them in place. Now, the second energy level has 4 bonding positions. I call them north, south, east, and west. These 4 bonding positions will each hold 2 electrons. Again, electrons want to be paired. But each of these 4 bonding positions must have 1 electron before any of them can have 2. So we have 4 more electrons to place. Let's start. But I'm going to start the count over. We'll go 1, 2, 3, and 4. All 4 of these electrons for carbon in this second energy level are unpaired. They're single. And the outermost shell is called the valence shell. The outermost shell is called the valence shell. So in its valence shell, carbon has 4 unpaired electrons. All 4 of these electrons want to be paired. How are they going to pair up? Well, they'll do so by finding another atom that has an unpaired electron, and those 2 electrons, those 2 single electrons, will pair up. Say, for example, we find hydrogen. Hydrogen is an element that has 1 electron. Hydrogen's 1 electron can pair up with any one of carbon's 4 valence electrons. When they pair up, they form a bond, a chemical bond, and that bond holds hydrogen to carbon. It holds the 2 atoms together. How does it work? 1 electron spins clockwise, the other one spins counterclockwise, and that creates opposite magnetic fields that bind them together like two magnets. So these two electrons get stuck together very, very tightly, holding this entire atom of hydrogen to the carbon atom. Well, let's say the same thing happens over here. We have a hydrogen. It has an electron. These two electrons pair up. And let's say it happens again here. Here's a hydrogen. Here's its electron. And these two electrons pair up. And we're going to let it happen one last time over here with a hydrogen, its single electron, and these two electrons pair up. Now we have a carbon atom that has 4 hydrogens, 1, 2, 3, 4 hydrogens attached to it by chemical bonds. In other words, we have a carbon atom who has paired every one of its single electrons with the single electron from a hydrogen atom. What do we end up with? Carbon with 4 hydrogens around it. Those sticks represent the electrons, the 2 electrons, right here. And we write this as CH4, and we call it methane. All living things are made of carbon. In other words, the major element that makes up all living things is carbon. And for that reason, all living things are called organic. Organic means it's made of carbon. Why is carbon the element of life? Well, simply, carbon's story is the story of 4. Carbon has 4 valence electrons, and each of those 4 valence electrons is unpaired. It's single, and it's going to try to pair up with another electron from another atom in order to be paired to become more stable. For that reason, carbon forms 4 bonds. Because carbon is small, it can form bonds with anything on the periodic table, and because it is small, these 4 bonds can come in multiple flavors: single bonds, double bonds, and triple bonds. In other words, carbon can form 3 distinct bonds, up to 3 distinct bonds, with another atom. Perhaps another carbon, perhaps a nitrogen, but it can form up to 3 bonds with another atom, or it can form 2 bonds with another atom, or it can form a single bond. When you look at the bigger picture, carbon is small, in fact the smallest element that can do all of this. Carbon binds with everything. Carbon can form multiple bonds. Altogether, this makes carbon very versatile. Carbon is also very stable, and it is still reactive. Now those two seem like opposites, but it is stable when it forms bonds, but reactive enough to form bonds, making carbon the ideal element for life.